is Getting Better, uh, our little presentation about Git. And um, we've already talked about the history of Git and the problem it aims to solve. So basically, now we made a directory and we got into it and we initialized a Git repository in our little directory. And so we've made this .git folder, which means that the creation of the Git repository was successful. So now let's create a file. And in it we will put some text. So now that we have a text file, we've made an edit. Oh, Benji's here. Um, so we made an edit to our file, and now the changes are in our working directory, but we haven't done anything to them yet. Apparently, I invited half of the people I know to this chat, so whatever. Alright, so now we have our file. We've saved it, but we haven't done anything to it from Git's perspective. So to do something about it, we need to add this file to the repository. And to do that, we use git add. Let's check out what we have so far. We can use git status to get the status of our repository. So we can see we're on our initial commit. And we have untracked files we haven't used git add on, and these files appear here in red. Now, there's only one file. If there were more, we'd have more files. So to add this file to the staging area, we will use git add example.txt. Now, if we use git status again, we'll see that we have changes to be committed. And this new file that we've added, example.txt, will be committed if we used git commit the next time. Now, the reason this staging area exists is because we can use it to have better control over our commits, what kind of changes we add in. So if I edit this file right now, the changes I've made after I used git add for the first time will not be included. If I edit this file again, we will see that only the changes I made for the git add will be committed. Thank you. Right. So now that we have our file added to the index, we can commit this file. By committing it, now, what we can see here is the default editor opened, and it requests the commit message. the changes to be committed, it tells us, it just puts the output of git status. And let's write the commit message, rant about Java. Right. So as we save, we can see that the commit was created. For every new file, we'll see this line that specifies the permissions and whatnot. So now we have one commit in our repository. We can hit git log to see it. In our log, we can see this commit ID, which is a SHA-1 hash of this commit and every parent commit we had. I'll get to that. The author, which is me, and the date in which the date in which the commit was made, and of course the commit message. If we'll have more commits, then we'll see these commits in reverse chronological order. So the newest commits appear on top. Yeah, Benji, no spam, please. Yes, it is. We'll get to the more nice stuff soon. So let's add a new file. And rant about Java some more. And now if we hit git status, we'll see that we have another untracked file. Now, if we edit our original file and add some extra stuff to our smiley, now git status shows us two things. We have a modification for example.txt, which we haven't committed, and we have this second example.txt file, which we haven't tracked. Now, we can add both files at once by using git add and passing a directory. Now, in Linux, and I think it's in Windows as well, the shortcut for the current directory is just dot. So if I add dot, it will add all the files and all the files in the subdirectories and everything in it. So I type git add dot, and we can look at git status again, and we'll see now that we have two changes to be committed. One, the modification of example.txt, and the new file, second example.txt. Now if we go to second example.txt and edit it again, this. Now we have a new file to be committed, but we also have modifications on the same file that will not be committed. Hold on. Alright, so now that we have our committed, alright, sorry. Now, if we commit right now, our changes for second example will not be committed. Only that first sentence I put in there, all the extra D's I entered um, won't be edited. So if we do want them committed, we have to git add the file again. And now we can see that it will be added. Yes, I shall commit to the D. And if we have git commit again, we can see that we have this extra output from git status again. Now everything that starts with a pound sign will be ignored, right? So rant about Java some more, and we will save the commit message. And now we have two commits in our little repository, right? So we have rant about Java some more and rant about Java. So now what do we do with it? I mean, we can commit files and we can do stuff, but let's see how we can revert back to a previous commit. All right, let's navigate the tree. So let's see, how can I draw? No, I don't think it should be in the advanced lecture. The basic format of how Git stores stuff is pretty basic. Well, apparently I cannot draw. Yeah, alright, we can do that. We can do that. Um, so um, let me share my bigger screen with our little recursive hangout there. And let's go to GitHub. Or rather, in my case, since we're doing private stuff, let's go to Bitbucket. Now, both GitHub and Bitbuckets are sites to maintain um, they're hosts for code, right? They're Git repositories you can push to and pull from. Let's do this. So we will create a new directory, a new repository. We will call it Getting Better. Now, as of now, when I create this is an entirely new repository, right? It has nothing to do with our repository yet. So, since we already have code in our little directory, we can link the two together using the git remote command. Now, what is a remote? A git remote is a completely ordinary repository that is hosted elsewhere. Git can access this remote repository with just about any protocol you can think of. Right? There's SSH, there's HTTPS, there's file, SMB, and there's the Git protocol, which is an extension of the SSH protocol. So since we already have um, code in our repository. There's the other way around of creating the remote repository first, then cloning it down. But we've started locally. So most sites will give you a nice set of commands you can use to clone your repo. So we want this git remote add. Now, this basically means git remote is the command add. Origin is the name of the remote. We can have more than one remote per repository, right? So we can push to one repository and pull from the other and do some fancy stuff. And this is the address for the repository we want to use. Now, this command doesn't require an internet connection. I can add any sort of remote I want without even it won't validate it until I try to push. So how do we push? Well, git push origin master. Right now, what's master? Git push origin is the name of the remote we're pushing to, and master is the name of the branch we're pushing. Right, we'll get to branches in a few minutes. If you have more than one branch, you can use the command they recommend here with the -u and the --all. Um, Not entirely necessary, but we'll do it anyway. And it will give us all sorts of crap. And now we can go to source, and we'll see our files there with our latest changes. You can see the commit messages and everything. So that's pretty nice. All right, we can kill that. Any questions so far? No questions so far? I can have many remotes, but only one of them can be called origin. Origin is a naming convention, right? I can call my remote whatever I want. I can call my remote Stack Exchange for shits and giggles. There are several conventions. Yeah, there are several conventions Git has. For instance, the first ever branch created automatically by Git is called master, the master branch. Um, Origin is the most common name for a remote, right? Because most people use Git as a centralized version control system. That is, there's one server with yeah, there's one server with a copy of your repository there. Now, Git in hosts like Bitbucket and the such, Git doesn't actually have a working directory. It only saves the commits and the tags and the branches and everything. And the working directory can be replayed if you replay all the commits from start to now. Now, it's important to realize that this centralized approach, while it's common, it's not a must. I and you can work on on a repository and push and pull from one another without having to go to any sort of server. So that's pretty nice. I can also set up an arbitrary server and start pushing and pulling from there, and I'm good. Um, in Git, there isn't a most important repository. Yeah. In Git, there isn't a most important repository in the system. Each repository holds equal value, and each repository is a complete copy of another repository. So if I push to Gem, for instance, and she has the same repository that I do. So if my computer is now lost and all my work is lost, she still has an entire copy of everything, including all of the commits made, all of the tags, all of the branches, all of the changes. Um, right. So now that we have these changes up on the cloud, yes, I can. And that's the strength of Git. As long as their computer is publicly facing, and its ports are properly written and whatever, properly directed and whatnot, I can access it as if I can access it through SSH or through a web interface, I can access it with Git, basically. Um, So let's show this demonstration. Let's get another directory, and let's say for this example that this is now another computer. I don't have the changes I've made over there. I'm another team member, or I'm working on another machine, or whatever. So I can go to this repository and get a clone link, and then I can git clone it to Getting Better 2, right? So this is a new command. Git clone will take a remote repository and clone it locally to any directory I want. Now notice this convention. Gettingbetter.git is actually a directory on the server. Alright, so in the bitbucket.org server, there's a user called Git, and in that called Git, there's a directory called Madara Uchiha, and in it, there's a gettingbetter.git directory. Notice how there isn't an actual copy of the files. Alright, this is the equivalent of my .git directory on the local repository. So we will clone this repository to our local directory. And now if we go into that Getting Better 2, we can see that we have both of our files here, right? And they contain all of the changes that we've made. And not only that, but our history is preserved as well. So now I can make a change for example.txt, and let's check our status, add the file, commit. Let's do something a little different. If I exit with an empty commit message, then the commit will be aborted, right? So you have to put any message in there. It's best practice that the message would be descriptive, and you want to be able to look in 6 months from now on this log and understand exactly what each commit does and why. So I'll just call myself someone else for now. It is and git config user password user. Oops. That's an actual email address, by the way. So now when I commit, I will commit as second Rikudo with that email address instead of my original email address. Now I bet that Bitbucket doesn't know second Rikudo on that email address, so it will not be familiar with it. Well, let's try anyway. Commit and about Java from another perspective. And now we have a change committed. We can git push it to origin, and we want our master branch pushed. And now that our changes were pushed, we can go back here, refresh the page, and we can see that we have changed from 28 seconds ago, which is a rant about Java from another perspective. Well, we can go into the file and see, but I really don't like it. Now, if we go back to our original directory, now the two repositories are not equal, right? Because there's changes in the server that we don't have locally. So how do we fix that? Well, there's push and there's pull. So we can git pull from origin the master branch. And now the changes made in the other machine are in my repository now. So if you go git log, you can see that second Rikudo from second at Madara Ninja ranted about JavaScript about Java from another perspective. This is basically remote. Alright, sorry, I didn't read the comment. Let me catch up. Well, Jem, you can, but this email is basically a throwaway. I mean, all emails at madara.ninja redirect to the same inbox, and I can block them selectively. So, yeah. I use Bitbucket because it allows for private repositories for free. GitHub is more of an open source kind of thing, so it allows you to open as many repositories as you want, but they're all public. So if you need some private project or whatever, you'll have to pay, which isn't a bad thing, right? GitHub does all sorts of amazing things, but Bitbucket does it too, and for free. So why not? Um, yeah, Vogel. There are a lot of Git shortcuts and commands and whatnot. Um, you can get to the man page, git log -help, and see everything that git log can do. It can do a lot, right? A great example is the git lg alias. You can go and look for it in the web. Git lg will bring you this more concise log, which is nicer. Um, the power of git lg, yeah, basically. The power of git lg really comes when you have branches. All right. Any questions so far? Yeah, branching will be next. All right then. Branches. Before we get to branches, we need to talk about the basic structure of how Git saves commits. So Git saves commit as a bundled object. The object has um, the commit message, the date, the delta of the files that got changed, and um, a pointer to the parent commit. So um, you can see that rant about Java from another perspective by Sagan Rikudo, its parent, the commit that's directly below it, is the rant about Java some more, and that parent is rant about Java. All right. So each commit holds a pointer to the previous commit, and this SHA-1 hash, which is this isn't the full hash. You can see the full hash here. This SHA-1 hash is a hash of everything, including the pointers and all the parents and the date and whatever. Yeah. So basically, um, every commit has a parent. So everything, right? The hash represents the status of the entire repository at that point of time, right? Because the Git object, the commit object, has represents the entire history up to that point. All right. If I make a change to the commit object in the .git directory, everything starts breaking down because now the hashes won't match. All right, so branches. You can refer to a commit in several ways. All right. You can see here that this commit is our head commit. The head is the commit we're currently standing on. I can change the head by checking out different commits and branches. We'll see that in a few minutes. We can also see that we have two branches on uh, on this commit. Now, if you're familiar with other version control systems, like for example in Subversion, a branch is a complete clone of the entire repository. Right. In Git, a branch is nothing but a pointer, a sign that points to a certain commit. All right. We can see that when we go to the Git directory, and we can see in our refs, I believe it is. Head no. You can see that in our refs heads directory, there's a file called master. And this master will have a file for each branch, and this master only contains the hash of the commit it's currently pointing to. So that's all there is to branches. Branch is merely a reference to a commit. Now, to when I add a commit on top of a commit that currently has a branch attached to it, the branch will automatically advance. Right? So right now I'm on the master branch. So if I add a commit, the master branch will point to this new commit I made. Right? Let's make a change so you can see it. Right, and committed. Now we can skip the staging area phase by just passing the -a flag to the -a flag to git commit, which basically adds all changes. Now my -a won't add new files, right? So if you create a new file, you need to specifically add it with git add. Now you can see that git log has this um, another commit um, another commit object. Now let's memorize the first few letters of our commit hash bf7. Now you can see that if we make another change, we can have git commit minus -a dash amend, which basically corrects the last commit we've made. So if you accidentally committed um, half the files you wanted, or you accidentally committed with a bad commit message, you can use dash amend. So um, let's even change our commit message. Now, if we head back to git log, we can see that we didn't get a new object, but the hash definitely changed, right? Because stuff changed in this commit object. It's basically a new commit object. So let's push our changes just so it's out there. Now we have several commits in our repository. Let's say this commit I made was a bad one. Right? It broke the build. It doesn't compile. It fails tests and whatnot. I don't want it. What we can do is we can check out a previous commit and start working from there. Now, Git is very strong with navigation. We can, using Git checkout, we can go to almost any place in our repository, right? So Git checkout accepts what's called commitish objects or commit personable objects. So what does that mean? Well, for starters, we have head. Head is the current commit, the commit I am now standing on. All right, so head would be this commit, this last commit that we've made. Now, there's also we can also check out a branch, right, like master. We can also check out if we know the hash, right? So we copy that, we can git check out that. Or Git is smart enough to even accept the first few letters of that hash, as long as it's not ambiguous with other commits. Right? Now, if you have, let's say, I want the commit, the one commit before head, so we can go head hat, right? Two commits before head is git double head, and 10 commits before head can be head tilde 10, right? So let's say this last commit is bad, and I want to work from our last commit, right? So we can check out um, head hat. And now, let's see. We are now in detached head state. You can look around, make experimental changes, and commit them. You can discard any commits, blah, blah, blah. So basically what we have now is that we are on this commit. There is another commit above it, which we aren't seeing because um, a commit can only see its parents, right? So we can now create a new branch from this commit if we want to. Now the working directory is also back at the state before I made the commit. All right. So if we go vim example, you can see that our third line is not there. Let's get back to master. Git check out master, and now we are back at our previous commit. Now let's say I want to branch here, right? I want to create a new branch and start working on it from here. Well, there's the git branch command. Git branch accepts a name, so we'll call it Gitting. Yeah, too much Gitting. Let's call it Vogel. All right. So now we have two branches here. We can use git branch and see which branch we're currently on and which branch we um, already have. And with git log, we can see that this commit is now also the Vogel branch, right? There are two branches on this commit. So let's change to Vogel. All right, we've switched branches. Now we can use git branch again. You can see that now the main branch is Vogel. And let's make a change to our files in this branch. Now we will commit it. Right? We can head back to the log, and now we can see something a little different. Right? We have our head on this branch that states on this Vogel branch, and this commit that states that Vogel loves Java. And there's also the master branch, which is behind the current branch. All right. So if we check out we will see the file, and if we go back to master and we look at the file again, we can see that Vogel doesn't like Java anymore. Now, if we want to push our changes, we will now need to go to Vogel and git push origin. And this time we don't want the master branch, we want the Vogel branch. Right? So you can see now it created a new branch called Vogel, and we can go to And we can go here and refresh the page, and we see that we have now two branches, master and Vogel. And when we go to example.txt, we can go to Vogel, and now we can see that these changes are here and not on master. Any questions so far about branching? Is there a command which adds all modified and new files while committing? There probably is, although I'm not familiar with it. I much rather explicitly adding the files or rather the directory. No, git commit minus a doesn't apply to new files, only to changes in existing files. Right? So if I create this new file and git commit minus a, won't let me. There's probably a flag on the commit command that allows you to do it, but just add the file. I very rarely used minus a. I much rather add the files because I often do long sessions of work, and I tend to not commit when I should. So I make changes to a lot of files, and then I add them individually and add the work in several commits all at once. All right, so that's one way of doing it. If you know you're going to commit every time you finish work, you finish a unit of work, go with git commit minus a and stage everything. Yes. All right. To add all files into the staging area or the index or whatever you want to call it, you can just git add dot. Right. I'm assuming that you are standing on the root folder for your repository. So git add dot will add every file and every file and all files in subdirectories and the such. Yes, that is correct. Add dot will not remove files. Right? Yes, either that or you can git rm to remove the file. Right? So git rm new will not do it because new isn't in the repo, but let's remove it for now. Now we have this branch, right? Let's say that in the meanwhile, the master branch also had some work done on it, right? So let's make change to our second example. And commit the changes. And let's push all branches. Now, we can probably, yeah, we can see all the commits on this, and we can see the branches we have. I'm looking for a nice little graph. Yeah, there we go. Now you can see here that these commits are on the same branch, but here at this point they split, right? So this is the Vogel branch, and this is the master branch, right? Now these commits, a commit is defined by the changes made here and all the changes in the parents. So these commits share the same parents, all right? Now work was done in master. I want to merge the changes that Vogel added to his branch, right? Because he finished work in his branch, and now we want to merge it in with the rest of the code. Yes, I can. All right. Jem asked if I can just use git commit dash m and end the message instead of doing the way I did. Well, yes. All right. I can go git commit my dash am and add a message here. But I hate this method because it encourages crappy commit messages. All right. It's great for example purposes, but the commit messages I make on my other project and at work are usually 5 to 6 lines long at minimum. So dash m doesn't really help you, right? It only hurts you because when you look at this, fixed a bug in example.txt, that's pretty much what you can write there. You know, you fix a bug in login logic of example.txt. That's pretty much what you're going to write if you use dash m. And that's not descriptive, right? I'll look at it in 6 months and I won't understand what I've done there, right? I'll have to use git diff and whatnot to understand, and that's bad. You basically want the commit message to describe everything you've done and why. Any other questions? Yes, you have less space to write message, and thus it encourages you to be lazy and write crappy messages. Any other questions? Alrighty then. Now, we have work on our colleague's branch, and we want to merge it in back to master, right? So in SVN, um, branching and merging is a real pain in the butt because a branch in SVN is practically a copy of all of the files in the repo, and merging means resolving the differences between all the files in the repo, and that sucks like a lot. Because Git branches are so light, they're basically just pointers to a commit. So when I merge, Git will resolve the changes based on the parent commits, right? So basically, it will, when I want to merge from master, I want to merge Vogel into master. It will check to see all the commits that are in master. We, all right, all the parents commits of the master branch, which are not parent commits of the Vogel branch, right? So right now, these 1, 2, 3, 4 commits are shared between the Vogel branch and the master branch. So there are no changes here to be merged, right? So the only changes to be merged are in this commit that states that Vogel loves Java, right? Is that clear so far? All right. So in order to merge is a very simple it's a very simple action. You go into the destination branch, right? The branch you want merged into, and just type git merge the branch name you want to merge in. And we will branch the Vogel branch, and this will automatically commit the changes. It's recommended that this merge commit will also be descriptive. That is, what kind of work was done in the Vogel branch and whatnot. Um, but we will keep it as the default message for now. And now we have these changes merged, and we can git push master, push origin master, and my connection sucks. And there we go. Now if um, we go here, we can see that this created this new merge commit with two parents, right? So this new commit, this is currently the master branch right there. We can hit git lg to see it as well. All right, so we can see the Vogel branch splitting off from this commit here. There were commits made here, there were commits made here, and this commit, the current head and the current master, has two parents. All right, each commit, except for the first one, must have at least one parent. All right, you can merge more than one branch. Um, but you usually want to keep it simple. That is, a commit can have more than two parents, but you usually don't want that. Just stick with the simple stuff. All right. So what happens in the case of a conflict? All right. So let's say Vogel, because the branch still exists, merging the branches doesn't delete anything, right? Oops, get check out Vogel. Let's say that Vogel wants to spread some more love about Java. Um, right? And commit. And let's say that on the same file, I wanted to show how much I despise Java, and I committed as well. Right? So let's push everything. And let's see how our tree looks. Fancy. All right. So now we have this extra commit on the Vogel branch, which includes some more Java 11, and another commit on the master branch that says some more Java Hayden. So as you may have noticed, the changes I made were in the exact same line um, on the exact same file. So now when I'll try to merge the Vogel branch, you can see that we have a conflict. Automatic merge failed, fix conflict, and then commit the result. Right? So the conflict are marked in our example.txt file. So if you go to example.txt, we can see that we have this um, this conflict resolution markers. Right? So this is the head. This is where I'm trying to merge into. And this is the incoming change from Vogel. So what I need to do now is assert my dominance and say that I really hate Java, right? Fix this um, commit conflict, remove the markers, and then commit. It's not possible because we have unmerged files. Right. I still need to add the files. Git add example.com, git commit. And you can see that it will still automatically add the branch name. Resolve conflict with love and hate of Java. Oops. And now, after we've done that, we can push. And we will see another merge commit here, right? And we can see what really changed here. We moved this change on the first line to the second line, and there we go. Any questions so far? All right, so I'm using Vim as my console editor. All right, in Vim, oops, if I open a file, I can make changes to that file, whatever, and then when I hit escape, I go back into command mode. And in command mode, I can hit colon WQ, and W means write and Q means quit. So I can just W and save the file without quitting, or Q and quit without saving. In fact, if I have changes, I'll need Q exclamation point to quit without making changes. It's just the way you save in Vim. It's an editor thing. Any other questions? Yeah, I press escape. And I to insert characters. This is the equivalent of, opening Notepad and making a change and saving and quitting. That's it. All right. Last topic for today is tags. A tag is an object that's different from a commit object. Um, it points to a commit, and basically use tags for things like releases, version bumps, uh, you know, uh, significant milestones, whatnot. Um, Using git tag is really simple. Um, you can see, for instance, there are two types of tags, really. Um, all right, I'll do that too. I'll do that too. In fact, I'll do that before tags. So let's say I've made a commit that is crappy, and I want to abort it. So let's say that, for instance, I accidentally said that I like Java. And that's an obviously blatant lie, but I already committed it. Now what do we do? Well, there are a couple of options. In case I haven't pushed yet, I can use git reset. Git reset will basically remove changes from the git reset will restore changes to the staging area to a commit you've specified. Right? So if I hit git reset, um, if I have changes in my staging area that I've added with git add, I can git reset and remove them from the staging area. Right? I can git reset a file, git reset to a commit, and all sorts of nice stuff. So git reset accepts a flag called dash dash hard. There, I'm getting there. Git reset has this flag called dash dash hard. Dash dash hard uh, will make changes to the working directory as well. Right? So git dash dash hard, and we want to cancel this commit, so we will reset to one commit before this. So head hat. And now our head is at the merge point with Vogel. Right? And this new commit is now apparently lost. The commit is still there, right? But as I continue to work, the garbage collector, Git has a garbage collector, and um, it will detect unreachable commits. Unreachable commits are commits that have no tag and no branch pointing to any one of their children. Right? So in this instance, this particular commit is referenced by this particular commit, and this particular commit is referenced by these two. And these two are referenced by this one. Oops, I hate it when that happens. And this particular commit is referenced by master. So this is an ancestor of a commit which has a branch, right? Get um, our newest commit. Let's get back to that for just 1 second, if we can. I don't think we can. Nope, we lost the commit forever. Oh no, there it is. Right. So now this commit doesn't have any branches pointing to it. Alright? It has no children with branches or tags. So as we continue to work, it'll take a little while and we can invoke it manually, but basically Git will garbage collect this commit and dispose of it. Right? So that's the git reset um, that's the git reset command. So let's check out back to master. Yeah, so you see, as I move away, it warns me that I have left one commit behind that's not connected to any branch, right? So this will be deleted at some point. Um, Another thing, git let's make a change to our file and let's lie once more and commit the changes. Now I screwed up big time and I also pushed it. What can we do now? We can't just reset and push the reset because that changes history and I will be fired if I do that. Um, Nor will it let me just push it. I'll have to use push with the F flag for force, and that will get me fired as well. So what can we do? Well, we have git revert for that. Git revert will create a commit that reverses the commit that I don't like. Alright, so I can go git revert head, revert head, and this will automatically populate with a default message. You can change it, of course, but I won't. And now we can see that we have two commits. One that says I lied again, and one that reverts the lie. And we can push that new change. And we can check out our um, our thing here. You can see that this commit adds a sort of like Java, and this revert commit exactly removes it, right? So this will do the exact opposite of the commit um, you passed. Now you can pass multiple commits to git revert. You can go git revert head to head hat. So this will revert the last three commits, right? Now this will create a distinct commit object for each reversion. So that's three revert commits. And last but not least, if you want to keep all the changes and just ignore them for now, with the lack of a better word, you can just git check out a previous commit and create a new branch here. Right? So now I can git check out master again, and I can still get to there by checking out after lie. Right? So if we go back to master, which is our most advanced branch, and just git LG, we can see that the master branch is one commit ahead of after lie, and we have this Vogel branch still here that we can add commits to. Now, another cool feature Git has is if you have a branch that is a complete parent of another branch. So what does that mean? It means that, for example, if I go, we have this example here. This after lie commit is behind the master commit. So let's make some more changes to master. And make even another one. All right, so now our master branch is quite a bit ahead after lie. So um, I can now bring this after lie branch up to date with master by merging. Right? Now, since all of the commits of after lie are contained within head, that is, this commit which is a parent commit of after lie is also a parent commit to master, and all of the commits that are parent commits to after lie is also a parent commit to master. So this means that we don't need to resolve deltas. It means that this branch, I can just do an action called fast forwarding and just bring this pointer to here. And that's it. So that makes this merge, this type of merges, very, very fast. All right. Now I can explicitly override that by saying git merge dash dash no ff, so that's no fast forward. But just to demonstrate it, we'll go git merge after lie. Right. Second. I probably did something stupid. Hold on. Hold on. We will fix your problems. Right. I need to get check out after lie and then merge master into it. And now we just fast forwarded the after lie into the master branch. And we can check out git lg and see that this origin after lie is where the server is at, and this is where the local version is at. So now if I push, you'll see that origin after lie is also here now. Right? So we can go back to our commits tree, and we won't see a lot of changes. But if we go to branches, merge, yeah, you can see that afterlife is here as well. Right? And just for kicks and giggles, that's not what I wanted. Source. In second example, you can see that even in the after lie, it's still the same file because it's the exact same commit. Right? Same hash. So this is where Git really gets strong because these branches are super light and super fast and everything happens locally until you push. I went through a transit from Subversion to Git, and it's just amazing how well pronounced this change is. Alright, questions so far? Yes. Um, that's a great question. My audio is clear because I have this sick headset, Sennheiser PC360, and the image being clear is I have no idea why. I just don't know. And I will blame Bitbucket for the lousy ping I'm having. Is there a way of editing just the incorrect commit message without reset? Well, yes, it is, and I've already demonstrated it. You can go Let's check out master. And we have this not joking at all, and we can go git commit dash dash amend. We can change the message here. All right, and that's just the latest. You cannot do this with an older commit because this will cause a history break, right? Because there's a more advanced commit that points to that commit by hash, and since that hash changes, all of the history above that commit will no longer be valid. So you can only do this for the very last commit. Any more questions? Will I hold the advanced class too? Sure, if there's interest, then I don't see why not. Tags, right. Right. Tag is pretty simple. Um, there are two types of tags. There are light tags and full so-called tags, lightweight tags and non-lightweight tags. Um, I generally don't use lightweight tags. Lightweight tags are simple pointers like branches, only they don't move. And full tags are actual objects that point to a commit. It holds a date and a message and a version and whatnot that you want. All right. So basically, uh, um, if I remember correctly, which I probably don't, but still, let's see what's wrong here. Uh, yeah, I kind of screwed up with that one, with that last one. Get get uh, 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 uh. Nope, I'm on the same directory. Right, now I'm up to date. Yeah, it's because that that commit dash dash amend I've made, it wasn't compatible with what was on the server. So what I did, I pulled the current state from the server and then reset it to that. Right, so now I'm at exactly the same place as the server, and my amended commit evaporated. So to use a tag, um, to add a tag, you need um, either dash A or dash S. All right. Basically, you want dash A. And now we can add, say, a version, and we can add an actual message. So release version 1.0 quit, and I can git push dash dash tags, push this new tag to the server who are remote, and we can probably see it somewhere around here. Overview, tags. Yeah, so you can see now this tag points to a certain commit. So it shows you exactly the state of the history at that tag. And I can also very easily, let's say, git checkout no after lie and git checkout version 1.0, and see now it moved to version 1.0, but there's no real branch here, right? Go to git log, you can see that we're at the tag, but we aren't on any specific branch. The current branch is nothing, right? So if I commit right now, that commit might be lost unless I create a branch, because we're in detached head state. So if I make another commit, you can see that our tag is still here. Our tag object will still point to that commit, even if all branches go away. All right. So a tag is unmoving. Okay, you can't move a tag. The best you can do is remove it and add it elsewhere, but you can't move it. Unlike a branch that always moves. So a tag is great for things like releases, for things like milestones and whatnot. Any questions? Yes, you can move a lightweight tag, but a lightweight tag is something I personally rather not using. I'd much rather have a proper tag with a proper message and a proper everything. Because it's more explicit. That makes it easier to read history. If I remember correctly, there's overview 1.0 or something like that. No, not show. Um, right, git show. Git 1.0 shows you who's the tagger. It shows you the date. See, a lightweight tag will not show you all these things, right? It doesn't point to a commit. It won't show you the diff. So a big tag is better for all things and purposes. Any other questions? Dash dash all pushes all branches, yes, but not tags. Right. What if I have many files to add? there a way to add them all at once? Yes. You go to the most common shared directory, or most commonly just the root directory of the repository, the same directory that has the .git um, directory, and type git add dot. This adds the current directory and everything below it. Now it's important to note Git doesn't save directories. If you have an empty directory, there is no way you can add it to version control unless you insert a file in it. Right? Git only tracks files, not directories. Alright, any more questions before we are done? This terminal, well, you're probably used to Bash. This is Zash, right? ZSH. It has all sorts of nice plugins and the such. You can Google "Oh my Zash" and you'll find it. It has lots of plugins and the such. I can also there's this if I do cd, I can do let's go into the git and the refs and the head and whatnot, and I can go get dot 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 or something like that. Oh, not git, sorry, cd dot 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 to get multiple directories backwards. That's another plugin. And it has all sorts of nice fun stuff. Yeah, that. Any other questions? Alright, folks, then this is where we conclude. If you have any other questions, you can ask them in our chat room. And hope you all enjoyed and learned and whatnot. And have a great time.